Hi everyone, and welcome to this fourth episode of our new series, The Future of Urban AI, co-produced by Cornell Tech and Urban AI. It's a great pleasure to welcome you today. So very quickly, an introduction about this series and this collaboration. So basically, we are currently exploring with Cornell Tech several possible futures of urban artificial intelligence. We already did 3 fascinating episodes on several topics such as participatory sensing, quantified canopy, and AI, urban system, and common sense with Ron Brackman. All of these episodes are already available on Urban AI YouTube channel, and we will explore much more episodes in the coming weeks on several topics such as self-preparing cities, geopolitics of smart cities, Internet of Nature, and today, CityScope. Some few words also about the methodology of this project and how we designed this program. So basically, what we did with Anthony Thompson, with us today, is that we worked on a really fascinating project he did with his team called The Future of Urban Tech. And basically, the future of urban tech, as you can see here, it's a 10-year horizon scan. You can explore it on their website. And the idea is that you can explore several possible futures of urban tech select interconnected futures with a dynamic graph. And what we did is to focus on the artificial intelligence, urban AI part of this graph. So really have a look to this great project. But today we have the great pleasure to welcome Ariel Noyman. So Ariel, you're a research scientist at the MIT Media Lab. You're also actually a member of the Urban AI community. And you are going to present your project, CityScope. So yeah, the floor is all yours, Ariel.
Thank you very much, Hubert. With a show of hands, can you hear me well? Okay, that was also a prompt to anyone who actually wants to show their face and join us in person. We were just discussing in the pre-meeting that it's about time we meet in person and physically be in the same spaces. We are taking advantage of Zoom, but I think we will all love to finally see each other. Now also tell me if you can see the presentation. Okay, sweet. Great. So thank you very much, Hubert, for this introduction, and Anthony as well for the invitation. It's really a pleasure to speak to you here today, wherever you are. I'm wearing many hats: Boston, New York, Tel Aviv, and you can basically find me in any of these locations. But today I want to really sort of focus on the work my team and myself are doing at MIT, working on the CityScope platform, as Hubert mentioned. So really just this year, we're celebrating our sort of 10th anniversary of the CityScope platform, and it's a good moment for us to reflect back and look into what we've achieved and what it is that we can do further on. But I think that before we discuss CityScope, I would like to spend a couple of minutes and talk about the state of cities today and where we are heading. And I think that, if you've been to any talk about cities in the past decade, you've heard that the world is becoming more urbanized than before. That's almost the cliche of all urban-related talks. But to put things in perspective, we're expecting about 2.5 billion people to move into the built environment within the next 30 years. The vast majority of this 1+ million inhabitants anonymous cities is not going to take place, I think, in the geographies that many of you are now operating in. As you can see in this map, we have large concentrations in Africa, Southeast Asia, and some of that in South America. And when we look closely into the patterns by which those cities develop and evolve, I think that we can, unfortunately, recognize a replication of many unsuccessful urban models. I call this really an urban tragedy, in which we keep on reusing and let failed urban models prevail time and again. And I think it's a tragedy because everybody in this room, and I think the general public would agree, that the city on the left is more sustainable, offer more economic opportunity, and even proven to be more healthy. But for some reason, we keep on building those cities on the right, We know that the street on the left is more diverse, safe, economically viable, and I think, frankly, more fun. But we keep on building those streets on the right. And in this case, this is from Seongdo in South Korea. We also call it a smart city. We know that the mobility modes of the left are more sustainable, healthy, and safe, probably also faster to move around in the city. But for some reason, we keep on surrendering our streets to those polluting, dangerous, and expensive modes of transportation we see on the right. And lastly, that mixed-use building on the left is providing walkable access to amenities and functions to all of the inhabitants in the street. But for some reason, we keep on building those monofunctional housing solutions all across those new cities. I argue that we don't build those new cities because we lack any kind of knowledge or that we have any sort of technological limitation whatsoever. They're also not cheaper in any way. So why is it? Why is it that we keep on developing our world the way we do? And I think that part of the answer, this is not the full answer, but part of the answer can be found in this photo here. These are 3 moments in the zoning code of the city of Los Angeles. I imagine that some of you might be able to decipher how to design the city in 1946, but I cannot even capture the 12 binders of regulations and zoning code in 2011, and today there are more. The thing is, the traditional planning processes tend to be slow, bureaucratic, and usually filled with complex legal terminology that promotes a lot of top-down and highly centralized planning processes, which collaboration, engagement, and public participation are becoming deeply undesired and pushed out of these processes. As a designer, this also reduces the role of design into the selection of forms, materials, shapes, details, etc., but in most cases not really focusing on the actual content and impact of those design features on the city. And so these issues motivated myself and my team at MIT, again, 10 years ago, to think about an alternative urban process through the design, development, and deployment of the MIT CityScope platform and evidence-based and data-driven urban modeling and simulation tool. We like to look at CityScope in those 4 major phases or categories: insight, transformation, prediction, and consensus. And I know that those hand-wavy terms are difficult to digest at this early hour of the morning. But for the rest of this talk, I'll try to sort of give key examples for each one of these sections and explain how we build CityScope through them. And so when we think about the first step, insights, this is really where we understand and represent the current state of the city. And in that spirit, sort of a toy model, a few years ago, we started with an urban observatory, a simple 3-dimensional canvas, which was set to observe the current state of the city. We projected different layers of information from land use to road network, solar or wind, and that was kind of a fun toy to play with. But soon after, we started a collaboration with the city-state of Andorra in between Spain and France, and got access to several years of high-resolution, countrywide, but anonymized location data. We don't know who the people are and where they come from. Still, using this data, we can start and understand movement, behavior, as well as where the locals and the visitors are visiting the country. And we can start and allocate where, hotspots are happening, traffic congestion, or the impact of large-scale event, which in the case of Andorra is critical because they have twice a year very, very large and massive events taking place, basically multiplying the population of the country twice and 3 times. With this kind of data, we can start and model the correlation between certain human dynamics and behaviors to the usage patterns of certain urban amenities. And that becomes a baseline for a tool that can help decision makers and policymakers in the city to understand what it is needed to allocate in order to create a certain urban phenomenon. And I think reversely, during COVID-19, since we already had these data pipelines in place, this could start and help decision makers in the city to understand which human activities are contributing most to the rise in cases across the country. I'll be happy to discuss this project later on in the questions, because we actually found some interesting insights in terms of discorrelation between what is the usual suspect for the rise in cases versus what reality actually showed us. But all of this information is good when we can make good use of it to propose transformations, to propose a change to the city. So the second phase of the CityScope is really where I think CityScope is shining as an iterative, real-time, collaborative urban decision support system. One of our first interactive CityScopes examined the very, very abstract urban concept, which I think most of you are familiar with, known as the zoning envelopes. This is the legal framework that determines the building usage, form, bulk, and its shape. Zoning envelope emerged in the early days of mass urbanization in New York in an attempt to protect the city from exponential development and growth, which started sort of damaging the quality of life for neighboring buildings, but at the same time created endless paper trail, which in some cases became unreadable by its own authors. And so the goal of this project was to codify the building code. That is, to translate the abstract legal terminology into computational building blocks so that the evaluation of new urban development could be done in a very logical way in respect to the current zoning law and building codes. Now, all of that was then encapsulated within this physical zoning simulator, in which, as you can see, the designers can basically do a massing exercise and get a real-time feedback on their fitness to the guidance, to the zoning laws, to the building code, etc. We also evaluated this system with planners, architects, and members of the community in order to compare traditional planning processes using versus using the CityScope platform. Now, about a year later, we've upgraded this platform for a major redevelopment site very close to MIT, in a site called Volpe. And in this case, we used CityScope to investigate a wider range of urban transformation. So not just zoning, but also microhousing, alternative mobility modes, and energy models. Now, this is sort of an open bracket to many of the other research topics that happen in our group, those mobility models and the architectural robotics, and some of you might be familiar with them. But we basically used and encapsulated all of these urban transformations into one unified CityScope so that we can measure and see what happens whenever we interact, whenever we propose any of these transformations. And you can see that as soon as my colleagues here are playing with the interactive Lego table, basically the KPIs update and change in real time. Now, all of that happened in the lab, but in 2018, we actually got an opportunity to test this in the real world when we were asked by the city of Hamburg to assist them with an international high-stake design competition for a site called Grassbook. You can see it in the bottom right, very close to the city center. This site is planned to become Hamburg's future innovation and entrepreneurship hub. Now, CityScope was not brought here as a design tool or sort of as a way to propose a design, but rather it was brought to evaluate different design proposals through the same set of metrics and KPIs. In other words, it reduced each proposal to its very rudiments in order to perform what we call, an apples-to-apples comparison, where the same sets of KPIs and metrics and models are used to evaluate very, very diverse and different design proposals. To those of you who are familiar with architectural competitions, they usually tend to be very, very fluidic and hard to decipher. Now, this approach is currently being used in many of our projects, and it's an open source platform, so you can all either use it or contribute to it. And projects from Vietnam to Hamburg to Detroit and Palo Alto are basically using the same methodology of sort of this reductive approach to urban analytics and KPI assessment. Now, we understood the city at insights, and then we proposed a few transformation. Now it's really the time where we want to try and predict as much as we can the impact and the trade-offs through various models and simulations. Now, this is a broad topic, and I'm not going to cover all of it today, but as you've seen so far, CityScope is pretty well suited to model hard urban systems, such as shadow, noise, water, urban form, or accessibility. But in the recent years, we've moved to model and simulate more implicit urban systems. And I'll give very quick few examples to that. Again, in Hamburg, we applied an agent-based simulation to investigate the impact of really microscopic interventions to the mobility habits of maritime tourists, really just the locations of train stations and bus stations and how that impact their access and movement in the city. A very similar project, and Hubert, we just discussed that before this talk. This was done in collaboration with the current host of Urban AI, PCA Architects. So a similar ABM was then used in Paris to examine a new master plan for the Champs-Élysées Boulevard, in which we've tested how new amenities and public and green spaces might potentially reduce motorized traffic, pollution, and emissions. So once again, we're not designing, we are using those simulations and platforms to evaluate a proposed design. But when we talk about prediction, sometimes the prediction is not about how the city behaves, but rather how the city might eventually look. And in this project, we're trying to sort of offer kind of a leapfrogging process where we don't wait for the renderings and for the architects to come into play, but as soon as we're producing a very crude massing exercise, as you can see on the left side, models, generative models, in this case, GAN models were used to basically simulate how the city might look like. Now, for me, it's kind of funny because this project already looks old. This is from 4 years ago, but those models are moving in crazy pace. So just in the past few weeks, we've offered a new version of that tool, where instead of the GAN models, we're using some of the newer technologies, the DALI and the Stable Diffusion and some others. And I think that's, again, open bracket, I think that there is a huge potential for these technologies to become an augmentation for the design process and for the design work that we all take part of. I want to close with the last theme of CityScope, which is consensus, because I think that everything that I showed you so far is not very different from what you might see in a traditional planning process. Might be faster, might be a bit more accurate, but it's always happening. We look at the site, we understand it, we propose transformations, and then we eventually try to predict our changes. I think what makes CityScope a bit different is by bringing these ideas together in a successful collaborative decision-making process, which involve many different stakeholders. So I want to explore just one use case, just one project in this context, which is one that CityScope was centered in a pretty heated and complicated decision-making process of refugee housing in Germany, in the city of Hamburg. So in 2015, we've struck a collaboration between the Media Lab, the MIT Media Lab, and the city of Hamburg through the Hafen City University there. And at the beginning, we were asked to look at the upscale development of the Alba riverfront. To those of you who are familiar, very upscale, beautiful place in the city center. And then we're also asked to look into the Olympic Village, part of the Olympic bid in 2016. But all of these first world projects had to be put on hold because somewhere at the end of 2015, the mayor and the city realized that a huge immigration wave is coming from Syria and Africa, projected to be of about 80,000 refugees and asylum seekers that were projected to arrive to the city by the end of 2016, an average of 500 people arriving every day, for which just German cities in general, but Hamburg for sure, had no viable housing solutions and basically relied on those very ad hoc responses. And so as a result, the public sentiment changed, and there was a large referendum and a pushback against the Olympics. So the mayor, Olaf Scholz, who is actually now the Chancellor of Germany, basically paused any search for the Olympic bid, and literally a few weeks later came to our newly established lab at the Hafen City University and said, guys, you have 3 months and very small budget to come up with a solution. And he didn't give us too many limitations. It was basically those three key criteria. It had to be a bottom-up, a citywide, and a collaborative planning process. And I like to show this picture because that's just for perspective. That's everybody that was part of the city science group at the time in Hamburg. really just establishing the lab and literally hanging the sign. But within a few weeks, the two teams basically copy-pasted everything we knew about public participation, community engagement, and the CityScope tools. And we basically structured a new planning process around those tools and around that agenda. And with German accuracy, exactly 3 months later, the Finding Places project was inaugurated here by the mayor, as you can see, holding a Lego brick, and basically starting a process that over the coming month hosted every night about 30 or 40 community members. Eventually, we had about 500 of them coming to these sessions. And the target demographics and members of the community from affected areas were invited to these sessions. And I really like that quote from the Die Zeit at the time, the Die Zeit newspaper, who said, this project is swarm intelligence, doing instead of complaining. And in a very German way, I was trying to portray it, if you have something to say, leave your home and come and join us in this project. A typical Finding Places session would include the introduction and insights into the current state of housing of refugees in the city, such as where they live, what are the designated locations for future housing, and what are the challenges in the places they're currently living in. Then the whole group would transfer into an interactive neighborhood scale CityScope on which those Lego bricks would mark the addition of housing refugees for each site. And here, this is a bit more technical, but the tangible user interface then translated all those interactions into basically GIS features, which then initiated an analysis in all the three different scales, the city, district, and the selected neighborhood. And then for each interaction, feedback on land contamination, zoning restrictions, amenities, access, and many other criteria would appear. So you can see some of that feedback happening there on the upper right, where users interact, and then the system is basically blocking them from proposing housing solutions for those locations. By the end of each of these sessions, each team would then share their feedback and compare with previous teams on literally how many places they managed to find. And I like to show that result page because I think it's sort of showing us how we can move from NIMBY to yes, we can. So overall, Finding Places had a measured outreach of about 1.2 million inhabitants or residents in the city of Hamburg, basically 1.2 million people who knew about the project. And over 160 sites were found by the public and given back to the city for planning housing for refugees on them. I think more interestingly is that while we were still conducting those meetings, several of these sites were then started to be constructed because we removed the hurdle of getting the local communities buy-in, and we can start construction, something that especially in German cities might take 5 to 10 years in normal processes. And I kind of like the quote again from Olaf Scholz, then the mayor, now the Chancellor of Germany, who was saying, Finding Places is your chance to examine what makes sense in theory is also suitable in practice. And I think he sort of encapsulated the whole idea of Finding Places, but of CityScope in general. It's really about testing and iterating between the different options and really understanding what are the trade-offs by yourself. And we see that as a very important part of the new urban planning process. Right, so to close, CityScope is now, Finding Places, CityScope in general is being used in many other contexts. Specifically, Finding Places is now used as a toolkit for the European Commission and these organizations to help with other planning processes, which involve both the public and stakeholders and decision makers. And in general, all of our city science network labs around the world are basically situated around the similar questions. They all have their own local and very specific challenges, but the tools are very similar. The tools are always based on that same starting point, and it's really nice to see how that tree evolves with different manifestations of the CityScope platform and of the tools. And in the pre-chat of this conversation, I mentioned to Anthony that I'm from Tel Aviv, so I'm happy to also announce that we're starting a new lab in the south of Israel alongside the Ben-Gurion University, and that's going to be another city science network lab in our deposit. And for sure, some of the issues and the challenges that we've discussed at the beginning, developing of the global south, would be addressed in this lab. So if you have an interest, or if you're related in any way, shape, or form to this world, I'll be happy to hear from you and collaborate. And yeah, and with that, that's about it. Happy to have a conversation.
Thanks a lot, Ariel, for this very inspiring presentation. That's really great to see like how technology can be used to empower what you called, swarm initiative. So that's super interesting. So if you have any questions, comments, feel free to use the chat. Actually, we already have one question from Antoine. So hi, Antoine. So he's asking, thank you for this very inspiring presentation. I'm interested in the way you translated urban code into programming code in the transformation part. Have you been using CityScope to detect flaws in urban code? So this is his first question. And second question, there are more and more awareness about biases in programming code. Were you able to using some techniques used in programming to get new insights about the impact of urban code?
Yeah, it's an excellent question. So I like to say that that transformation project, the one I was mentioning about zoning, is really a prehistoric project from a technological standpoint. It's a pre-AI tool. It's really using what we usually like to say when we talk about AI, that in the past people were coding basically all the statements and all the rules by hand, and now AI can replace that. So that project was really doing things that in that traditional historical way. So today, if we were to confront this question, we're probably gonna use some of the more modern tools, those that can decipher language and that can do some NLP to understand the legal terminology and try to compute it. There are challenges there, and I think your second question is really touching upon those challenges, where when you give the algorithm the capability of understanding the text, you don't necessarily know if the algorithm did a great job, especially if it's a large corpus of text, and that's where many of the biases that we're seeing today might emerge. Again, that project was really in the prehistoric moment where we modeled everything by hand. The other side of that challenge, of course, was that when we saw, we did it for Cambridge, and when we saw the amount of legal terminology that we have to confront, we basically had to reduce it into a very, very specific and small site. If we wanted to do it for the entire city or the entire region, that will take a group of a lot of people. I would just say that there were a few, at the same time when we did that, there were a few other companies that were trying to do it. Google was actually playing the same game with a company called Flux. There was another group working from MIT and then got sold to Shop Architects that were thinking about the same idea. So basically taking zoning code and regulation, basically building them into algorithms. I think that they all found at some point that this is an extremely challenging problem that usually would still require a person at some point. So yeah.
We have another question, several other questions actually. First from Max, who is asking, have you explored, tested this community design process in a completely virtual context? Or do you feel that having people physically place the building does it make it more valuable to have people in the same place?
Yeah, thanks for that question. It's funny because whenever I've been asked this question, I always said, yeah, it's much better to be in the same place. And then we had COVID, and we've spent 2.5 years in remote environments, and now I have to sort of defend the need to actually be physically in the same place. We've done a lot of, so I'll answer that in two ways. First, from sort of the scientific point of view, we've done a lot of HCI research to prove that the type of communication and collaboration that happens with those unseen cues between us when we are in the same space, we're in the same room, are significantly better than those happening on virtual environments. Actually, each one of those CityScope platforms that you've seen was deployed both digitally online as well as physically in space, and we can easily compare the quality of conversation and design and output from each one of these sessions. So this is some sort of kind of from the scientific side of things. We sort of show that the physical is much better. But I would say just in plain view, if you were to interact with CityScope, if you were to come to our lab or to go to any of our community engagement sessions, I think you would see firsthand that there is something happening in which the physical table, is just becoming kind of a common ground for a conversation. It's not the focus, right? It's not, the tool doesn't make anything for you. It's not sort of a generative, sophisticated algorithm. It's really a basic way for you to start a conversation and test some of your assumptions in real life. And what usually happens in those successful meetings is that the tool is the center of the conversation for the first 5 minutes, but then everybody goes into a very, very kind of active conversation. And that is something we never managed to replicate and recreate in an online environment. So, I don't have stocks in Meta, and I don't know where the metaverse is going to be, but I'm very skeptic that we'll be able to replicate those qualities with virtual and technological tools.
Another question from Anthony, who's saying it's important to highlight that most of the innovation here is process. Secondarily, visualization and analytics, and only third is AI, and it is used wisely in a very focused and limited way. Are there other opportunities to employ focused AI on the horizon?
Yeah, thank you, Anthony. That's a wonderful question. There is a term that I started using recently, which goes AI on the shoulders. And I guess you've heard that before. And it's a term that I think some of the industry is starting to acknowledge, because sort of the leading AI researchers were in this mode of, we're approaching global AI or AGI very soon, right? That was sort of the notion of, let's say, 2017 to 2020 or so. Like, there was this boom of AI. Everybody were kind of expecting that AI is going to take over the world. And now they sort of hit a wall, and they realize there is a limitation, and a very clear limitation that they can draw between what AI is capable and not capable of doing. And then I think now there is sort of a realization that until AI would be as good as a person in whatever task they have to do, they will only be on the shoulders. And when we, I think, intentionally put them on the shoulders, they could become an extremely valuable tool in the design process. I always say, when I started my architecture professional life, you draw a line in AutoCAD. The AutoCAD helps you to keep the line straight, right? It's not AI, but it's an algorithm helping you to draw, better than what you draw by hand. So a multiplication of that thing would be an AI, right? That instead of just drawing the line, draw the entire floor plan. But that's just, an adjustment to that thing. You write a sentence now in Gmail. Gmail helps you to complete that sentence. It doesn't replace you. You're still there. There is a man in the middle. And I think that this dance of AI on the shoulder is really the dance we need to inject into our design and planning processes. I think it can automate many tedious and kind of complicated tasks that take a lot of time. But as you said, I mean, it's really about being careful where we inject it. It's not too much, it's not too little. It has to be in a very, very particular space. And I think we're just starting to scratch the surface on what is that dance and how it should look like.
We also have a question from Masha from Edinburgh. Thanks for sharing your insight. What are the main factors you consider when deciding on the level of abstraction of the city within the CityScope models? Yeah, thanks for that question. We started that whole thing with the Legos and the abstract model of the city. And at the beginning, it was really just about creating a medium or using a medium that is not intimidating. When you take business school students and you try to talk about a city and you give them a cardboard model, they're afraid to touch and look at that. But you give them a Lego model, they have an immediate connection, and they don't afraid so much. What started as this experiment
soon became sort of an ideology when we realized that when we reduce and when we sort of kind of flatten the form and the shape of the buildings, we disconnect ourselves from a design discussion into sort of a meta discussion about the qualities of that neighborhood. So people don't care so much about the form of the building, the shape, the materials, the facades, the many things that usually are in the center of the design discourse nowadays, but instead they just look into how the building function, how the neighborhood is functioning, what are the movement patterns, the energy, the emissions, all of those questions, which I think are the critical ones when we talk about urban development. And so that reduction is actually working for us, I think, in a sense. But again, since CityScope is a technological tool, it can always go higher and higher in resolution and get to the point where you can actually see the building. We think that our contribution is really in that meta planning process. There are many, many tools that are helping you to better design down the road.
Other question from Anthony. Does using AI create other challenges, like making it harder to get people to trust the process because they don't understand how it works?
Yep, definitely. The black box problem, which is critical in this process. I will say, not even AI, it's just the technology in general. So every time we had those CityScope public participation or community engagement sessions, if we weren't very careful on the way we presented the technology, we immediately got resentment on, hey, I don't know how this algorithm works. Not even AI, just the simplest energy model or the simplest walkability model, right? I don't know how it works. I'm pushing back. And we found that we have to be very, very cautious on the way we present those models, as well as from the get-go present that everything is open source and that the models are questionable and that there is research behind each one of those models and they can approach the papers. It's not that it always happens. I'm not expecting everybody in the community to go and read a bunch of papers about energy modeling, but you have to create this sense of connection. Otherwise, there is a pushback, and I think AI is just increasing that challenge, right? The researchers themselves don't really know what might be the output of their model. I'm just I'm quoting the people from Stability AI, those who just released the Stable Diffusion model, how shocked they were when they saw the first result of their own model. You guys designed it, right? But the first time they run it, they're amazed by the results. And this is, I think, where we are really with this world of AI. We create something which is somewhat more powerful than we expected. And then when we employ something like that in a planning process or in a community process, that may be a significant challenge.
Several other questions, actually, Ariel, if you still have some time.
I'm good.
Christopher is asking, did you find the data gathering steps to be an issue, or is it all embedded in the framework? How long does it take to set up a table?
Great. So I think at some point we realized that gathering the data and cleaning it up and sorting it out is part of the product. It's the common cliche about data science, where 80% of the time is getting the data, cleaning it, and 20% is actually building the model. In CityScope, it's I think 95%, because we approach cities and municipalities that never had a data, pipeline set in place, to the point where you might find it ridiculous, but we get to cities and their drawings of their own buildings are incorrect to the point where, it's not just 1 or 2 meters. It's like really buildings are in the different location, or urban functions are not positioned where the city imagined them to be. Now, the first step in that sense is that we usually tend to create data sources for the city. So we create those pipelines. I mentioned that in Andorra, a big part of our work was not really to model or to do any kind of simulation. It was really just to build proper pipelines so that the city understand itself and understand what's going on internally, and then start and having analysis, insights, transformations, etc. And so that's I think it's a great question, because really the data pipelines are really important, and building them and creating them is a major part of our work. In a sense, setting up a CityScope is I think 25 minutes work if you have the data And if you have the analysis, the big part of our project is really to create that data pipeline, and then setting it up is not a huge challenge.
Well, actually, you already answered the question from Paul, who asked how portable are these projects between cities and what data standard would be helpful. We have another question from Max, maybe who is interested to launch a CityScope lab, because he's asking, how do you approach creating a new CityScope lab? What kind of partnership is it? What kind of support do you require? What kind of support do you provide?
Right. So I will answer very quickly just on Paul's second question, because the portability, which I think taps into Ken's question as well, the portability is really a question of how similar the data is between different cities. And so if we operate in Boston and then we operate in East Palo Alto like we do now, there is a lot of data portability between those two places, because they're sitting on very similar data sets and sort of metrics that we can aggregate before we start a project. But when we go from Boston to the south of Israel, that's a whole new story, and that's a whole new kind of a process. And so I think that's really sort of the challenging moment. Setting up the CityScope is not a big problem. It's about creating the data pipelines and then trying to see whether these data pipelines can fit to any of our models, and if not, we might have to sort of reduce our complexity and our accuracy as well, and get the models to fit whatever data exists over there. But again, I have to put all of that within the bounds of, this is only a starting point for a conversation, right? So the model, as accurate as it would be, doesn't replace the need for decision makers, stakeholders, and the community to understand what are the impacts of their transformations. And for that reason, we can have a better or worse data. It's really about creating a conversation around the design.
And so we had a question from Max, who was wondering, basically, how do you create a new CityScope lab? What kind of partnership is it? What kind of support do you require the new lab to be able to provide? And what kind of support do you provide?
Yeah, so we can discuss that offline, but I guess in general, most of our labs are basically long-term partnerships. That's a critical thing for us. I mentioned that briefly with Hamburg. You've seen that there was a series of projects, and I always like to say that the Finding Places, the refugee project, would never happen if we had a short-term collaboration with Hamburg, because we started based upon the idea of helping them with the Olympic bid, but then suddenly in 2016 everything flipped and they had a wave of 80,000 refugees. For a short-term project, for a McKinsey consultancy fee, we would be fired, and the city would look into other paths. Since we had the lab in place, we had researchers working full-time in place, creating some research for the city when the refugee crisis started. That allowed us to sort of switch gears and go into the refugee problem. And I think that's a critical part in all of our collaborations. It's not about setting up this or that CityScope project. It's about creating a long-term collaboration, which part of that is the CityScope process. The first phase would usually be the data collection and creating those data pipelines. And then we basically go into a longer process of either creating insights for stakeholders in the city, and slowly moving into public participation and engagement with the rest of the steps.
And finally, we have a question from Ken, who is asking, compared to your current ideal version of the CityScope, what are the key not yet existing features function? Yeah,
long list. We can do quite a lot. I guess that sort of taps back to some of the questions we had before. We would love to see more robust data pipelines that are easier to connect to and that are more open. One of the things we're trying to avoid as much as possible is either acquiring data or using data which is proprietary and is sort of closed, because that makes it very hard for us to go back to the city or to the public and say, we know what the source of this data is and how it's been collected. The more open data we can get, the more open models we can use, the better. And that's something we don't see quite a lot, especially when it comes to behavioral data, movement data, traffic data. You know, we've got a few very powerful organizations holding these data sets around the world, and we would love to see more and more of that being opened up. So that's, for me, would be a very, very important starting point. After that, the sky's the limit. Everybody's welcome to join the group or help us online to push the tool further, and there is really no limit on where you can take it.
Thanks a lot, really, Ariel, for this very inspiring presentation, for taking the time to answer all the questions. That's already the end, actually, of this session. The recording will be available in the coming days in our YouTube channel. If you want to explore further this topic and have a look to Ariel works, projects, research, I put in the comments his website. So have a look. That they are all at least as amazing as what he just presented. Our next session, it will be actually next week, same time with Replica. And this time we are actually going to talk on connected topics. It will be about synthetic populations and agent-based modeling. So thanks, everyone, and have a great week.
Thank you, Bert. Thank you, Tony.
Thank you, Ariel.